Okay, so this is a question that one of the lads last week couldn't do, and I'm just going to go through it here just to see how we'd approach it. So we'll underline the key parts first. So it's basically 2015 question C1 part C. So bit of context. I also remember this question, and we had a student a few years ago, and he should have been able to make an attempt at this. He didn't. He ended up 2 marks short of getting an A1. He got an A2. And you'll just see how he could have attempted it, and we'll look at where the marks, what marks he would have got if he'd made an attempt at it. So anyways, so it says a lake is located in the area marked L. So that's basically this blue area here. So it says the surface of the lake is an altitude of 50. So I'd write 50 on that, just to make sure, just so that we know. The line ST represents the center line of an overflow pipe from the lake. So basically, when the lake fills up above 50 meters, basically there's going to be an overflow here. It's going to take the water away for whatever reason. I don't know why. Maybe it's to stop flooding or something like that. The pipe travels from point S, so it comes from point S at an altitude of 50. So that's sort of saying that the lake is at 50, or that pretty much it's at the same height as the lake is at the minute, to a manhole located at a point T. So T is a manhole. So the first thing I suppose that we just need to be aware of is, well, what's a manhole? So a manhole is basically a hole in the ground, and usually it's a cover on, like a sewer cap, maybe if you're used to seeing them from the American TV shows. And basically we can get down into that, and there could be a valve or something that we can turn off, or we can check it for maybe debris or something that goes into it. So the pipe falls uniformly at an angle of 10 degrees. So there's our important thing. So it's determined indicator meters the depth of the pipe vertically below the ground at point T. So basically it's going to start at 50, it's going to go down at 10 degrees, and we're going to look at point T, and if we look at point T is at 40. And from that, then we're going to see, is that down deep enough, right? Is that down far enough? So, or how far down below that is it going to go? Sorry, I was just looking at my screen there. I'm hoping this is recording. Okay, so that's basically that. So the first thing that I would do is, I printed off the market scheme just to have a look at it just before we start. And I suppose if you couldn't do it, it wouldn't be the worst thing in the world. This is worth 3. Right, so I went to examinations.ie, I looked at 2015, and I printed out page C1. So the reason I did this is because of this unusual thing that I know came up on it. And it seems unusual to me because it's something I wouldn't have thought you would have had to show. Now, it's hard to know from the marks, if you didn't do it, would they still have given you the marks? And I'll explain how about that in a second. But basically it's worth 3. So 3 over 45 is basically 6.666%. Okay, so if you couldn't get it, it wouldn't have took you out of the A category if you got everything else. But as I said, this person ended up 2 short, and if he got 2 of these 3 marks, he would have been able to get it. And he didn't attempt it. Now, the first thing that we should know, yeah, I thought it might have said something about a profile, because usually if we see these lines here, they talk about a profile. And if it was me, I would have drawn a profile here because I think it's easier for us to understand what's going on. So this point here is 40. Right, so I would have measured up 40 and drawn that. Now, this bit here is the bit that worries me in the thing. It says X1, Y1 parallel to pipe ST. So I'm just going to come up 10 millimeters and draw a parallel line. Now, I wouldn't normally do this. I would actually typically have drawn it just measured up from there, because I would have been using the XY line on top of the line TS. And I assume if I did that, I would have still been fine. But just for the sake of making sure, just in case this comes up, and in case that's the way they mark it in the marking scheme, I'm going to draw another line parallel. So this is basically my elevation line. And what we know is we have to project to that line at 90 degrees. So I'm going to draw my various lines. And this, when I looked at the scheme as well, this isn't something that you have to do. But to me, this makes it a lot easier for you to sort of see what's going on, especially if you're not fully understanding what the manhole thing means and that like that. So this is 40. This is also 40 here. So maybe I'll use a green just because it would be a hit. So this is 40. This one here we follow around is 45. This one here is 50. And this one here is 55. And then we know the lake is at 50. So basically, this is basically what my scenery looks like, and I'd have my lake then. My lake would look something like that. Okay, so hopefully we can see that there. So what they said basically was, we have an overflow pipe. So a pipe is going to come down here. And we know that it comes down at 10 degrees. So in order to do a 10-degree line, what I need to do is I need a protractor. I can't use my adjustable set square, because the problem with my adjustable set square that I have here, if I set it to 10 degrees, it's 10 degrees off the straight across T-square, rather than 10 degrees off this line. So I need to get my protractor. So I'm just hoping I have one here. Yes, I do. Okay, so this is my protractor. So what I'll do is I'll just draw a parallel line again, parallel to this, just to measure my 10 degrees off it. So I'll draw it here, using my sliding set square method. Okay, that line there is just parallel to that, just to measure, and they're all parallel. Okay. So this is my 10 degrees. So again, now pipe would typically be an orange colour. If it's sewer pipe, it might be black as well, but we'll draw it in orange. Okay. So now I know that will be how my sewer pipe. So basically what will happen will be, when there's too much rain, maybe there must be flooding or something over here that's important. What would happen would be, or maybe it's that they're afraid that if the water went up above this, it would flood down to this valley. So the water will be taken away through this pipe. And what they said here is basically there's a manhole here at T. Basically T is here. So what that means is basically I can open up here, there's a sewer cap of some sort, I can open up, and they said in the question, determine and indicate in meters. Now this bit is important. It says determine and indicate in meters. So I have to write a measurement on that, right? The depth of the pipe. So basically, this here would be my depth. Right. Basically it would be that. So to me that looks to be 5 meters. Now again, I may be plus or minus a little bit because of accuracy and the thickness of my markers. Okay, so I'd say probably 3 to 7 meters is probably the answer. I don't know exactly what, I don't know if it shows it on the solution or not. But that's basically it, and that's that. So what they would have done would have been, if we look back again from accuracy, excellent, so they gave me 1 for this. They gave me the auxiliary view of the pipe ST, so that was basically this orange line. If you look at the solution, they'll see they haven't drawn the profile. But as I said, sometimes the profile just makes it a bit easier to see what's going on. And then it says determine and indicate the required depth. So I've determined it, so there's 5, and I've marked it in and written 5 meters beside it. Okay, so that's basically my scheme. And also, the handy thing about using the solution, and it's a good idea if you're trying to revise, is that it often gives you the steps on which to do. So if you're not sure how to do it, sometimes this can give you the hints in terms of what you think you should be doing first. Okay, so hopefully that's helped, and you can try that. It's relatively quick once you understand how.